Hello, this video covers College Algebra 3.1 about graphing. So in Chapter 2, we've covered single variables where we learned how to isolate a variable to find a single solution. So in this next chapter, we talk about adding a second variable and what that means. And we have a few interesting things happen. So we did have a few problems in Chapter 2 with those crocodiles where we saw a set of solutions. There were multiple solutions for things that would be like greater than 3. So 4 is greater than 3, 4.2 is greater than 3, an infinite number of numbers are greater than 3. But all of those numbers were able to be displayed on a number line, which was a single dimension. So when we add this second variable, we add this next dimension, the 2 dimensions, and we see the Cartesian coordinate plane kind of help us display these solutions. So just to kind of make sure we're all on the same page when we're communicating about these solutions, we all, math nerds got together and had a meeting and we decided to label them like this. So they called as an ordered pair with the x coordinate labeled first and then a comma before the y coordinate. Hopefully you've seen this before, and it does look a little bit like our set notation that we looked at in Chapter 2, but just be careful because whenever it is this ordered pair, usually the context kind of helps you see that it didn't mean that these were the numbers between -2 and 1, like we might have had in our last chapter, that this is one single point on the 2-dimensional plane where we went left 2 units and then up 1 unit. So this is to describe a certain point in the 2-dimensional space. So the x value, the first number, describes its position moving left and right, where of course the positive moves right and the negative moves left, just like we did on our number line. And then the new y value describes the movement up and down. You have to make both movements, the left-right x value and the up-down y value, to make one single point. So it's not saying to make a dot 2 units left and then an additional dot 1 unit up. This is one single point that has moved both 2 units left and 1 unit up. So I know a lot of this seems very familiar and you're going to think I'm over explaining, but as we increase the difficulty in kind of getting to new stuff, sometimes what was obvious at first seems a little tricky. So just come back to this point, kind of refresh on that if needed. So first off, if I have some points already on the graph, let's label them using these Cartesian coordinates right here. So if I wanted to describe to somebody where this position A was, and I had this grid laid out, I could count my units back. So 1, 2, 3, 4, 5, 6, 7. So notice this -5 is just kind of a placeholder here. So we went 7 units left. So if I wanted to label A here, I would describe him as 7 units left. Remember that number is going to go first, and then I'd count up. So I'd be 1, 2, 3, 4, 5. There's the 5, 6, 7 units up. Since it was up, we would use a +7. Okay, apologize for my handwriting. I know it's not the greatest. Okay, next, if we have point B, okay, I'm going to get better, I promise. Okay, B, you may notice, is 1, 2, 3, 4, 5 units back and 2 units up. So I mentioned this about the 5, just because sometimes when a dot or a number is close to that 5, it's easy to just kind of lock onto that number. So I'll have a lot of students have a point like here, and then they'll just see the 5 and automatically label a 5. So just be careful in situations like that where not every single number is labeled, that you don't just kind of automatically think it's that number it's close to. So I counted back. It was left 5, so I did get a negative, and up 2. So coordinate B would be described as -5, 2. Now point C here is right on the axes. Okay, so he actually did not move left or right. So for the x value, I'm going to put a 0. And then I went straight down 1, 2, 3, 4. So here's one of those situations where I would have a lot of common mistakes on something like this, where people would put the -5 instead of -4. And then a common mistake like I almost made right here, see, we didn't go up 4, we went down 4, -4. Clean that up just a little so it's clear. Okay, so just be careful with those positives and negatives. It's really easy to overlook. And like I said, sometimes when not every single number is labeled, it is easy to miscount or just see that closer number. So those are our labels here for the 3 dots that were made. Now, if I did want to label or plot these points that are labeled here, I'm going to use my colors. I know on your paper it's not color coded. If you do have some colored pencils, that can help. Or if you wanted to make some letters or something for these guys, whatever you needed to kind of help yourself coordinate these. So 2, -5, it's not up 2, that would be right 2, and then down 5. So 1, 2, 3, 4, 5. Okay. So this point right here, 2, -5 would be right there. Next, I would have, let's skip him, we'll come right back. 3, 2, 1, 2, 3 units right, 2 units up. Okay, next we've got 4, -3. That would be 4 units right, 1, 2, 3, 4, and 3 units down, 2, 3. Okay, I've got 6, 4. So 1, 2, 3, 4, 5, 6, and then up 4, 1, 2, 3, 4. Okay. Now this guy right here, these last 3 are just a tiny bit trickier, but don't panic. So 0, 1, anytime there's a 0, just be careful because it is easy to get in a hurry and put it on the wrong axis. So if it's 0, 1, just like this C value right here, that means it went 0 units left or right and 1 unit straight up, right here. So if I made the dot here, let me make another dot. This would be, okay, sorry, the computer messed up there. So this dot right here would be instead the point, let me fix this real quick. Okay, so this dot right here was this one listed as 0, 1. If I had this dot right here, I know I'm going to have to repeat in color, he would be 1, 0, because he would be 1 unit to the right and 0 units up or down. All right, now these last 2 with fractions, I know everybody loves fractions. If you needed to, just like we talked about in the section with the number lines, you might be a little bit more familiar with the decimals. So if it helped you, you could type in the -5 divided by 4 in your calculator, and it would tell you that it is equivalent to the decimal of -1.25. Okay, so we're just going to kind of eyeball it on here. So 1.25 would be a little bit past the 1, closer to the 1 than the 2, and then up 2. So the main reason these are in the examples here is I just wanted to show you that you're not limited to basically your 400 dots right here on the crosshairs. There's actually infinitely many points on this graph right here, because you could go just like we did here in between on the line right here. I could even have a dot like right here and say that that was -2.2 and then 8.1. So there's infinitely many points. I could even have 8.12637. Okay, so that was this guy right here. I labeled him with red. Okay, and then one more, make another blue. 4 and -3/4. Again, if I needed, if I wasn't super comfortable with the fractions in my calculator, I just type in -3 divided by 4 to see that that is equivalent to -0.75. Okay, so that means I would go 4 units right and then down, not quite 1 whole, but a little bit closer to 1 than 0. Right there. Okay, so that would be these points labeled just like that. So we see in our dots here that we have 4 separate planes, 4 separate squares. Okay, they do label those. It kind of comes in handy every once in a while just to have this, this label, because there's a kind of trend that the numbers in each quadrant have. So of course in quadrant 1, we have all positive numbers because we went to the right and we went up. So both the X and Y values are positive. You can see kind of the trends here for the other quadrants. They are labeled counterclockwise. kind of a silly thing that I use to remember the numbers of the coordinates is I say C for the quadrants, but that's silly because they're labeled with a Q, not a C. But that way I remember it goes 1, 2, 3, 4 in this direction. So if that helps you. Something silly to remember. So introducing this second variable, the reason we need both of these is because this gives us a breakdown of how to compare numbers that follow a certain trend, that follow one another in a certain way. So we're able to identify patterns in solutions where one influences the other. We generally have an independent variable and a dependent variable. Depending on what I input for the x, is usually our input, we get a certain output for our y. So if I knew the pattern that they were followed this equation right here, I could actually find which data set followed that pattern. So I have a couple different options in how to do that. Usually what you do is you just kind of start testing values. So if I knew that these inputs were put in, I should be getting these outputs out. So I'm just going to test one out. So this one has a 0 as the x input. So here I go. I'm going to replace this x with the value 0, just like when we were testing in chapter 2. So we'll just place that in place of the x. And I figure that up. If I need a calculator, if there's ever fractions or scary numbers, I can just punch that in. 2 times 0 plus 1. 2 times 0, of course, is 0. And 0 plus 1 is 1. So that checks out. Putting in a 0 does give me a 1. So I'm leaning towards the solution. But look, if I'm looking at my other options, this one said 0 should give me a -1. So I know it's not this data set because he was not correct. But this one also had a 0, 1. So it might be this one as well. So that means I'm going to need to test at least one more data set. So this one says that if I input a 1 for the x, I should get a 2 for the y. So let's check that out. So if I put a 1 in place of the x here, then I would get 2 times 1, of course, is 2, plus 1 would make a 3. Just like this one here. So this one said that my output should have been a 2. That was not correct. So it's not this data set as well. So the actual solution, the data set that matched this pattern, is going to be the last one. So if this were a multiple choice question, this would be your answer. You could just triple check that by picking this next point, plugging in the 2 and the 3, and it all should work out. Okay, so we've already picked the answer. I'm confident that's the one, but if I just wanted to be extra sure, I could check these last 2 solutions. And sure enough, that gives me the 5. And then this one, plugging in the 3, does in fact give me the 7, because 2 times 3 is 6, plus 1 makes 7. So this is the only one where all of those solutions will match up. Now this right here kind of goes the other way. Now this is a little sneaky because, like I said, we typically find that x is the input and y is the output. So this one, it kind of switched things up. It gave us a pattern where the y is used as our input, and then on the other side, the x is the output. That's okay, we can work with that. So like I said, this is a little bit unusual, and we're going to find out later why this is actually a little bit more unusual than you might think right now. So it doesn't give us numbers to test out like this one. It actually gave us kind of a picture. But remember that in this picture, we have unlimited ordered pairs. So what we're going to do is we're going to kind of find some pretty ordered pairs, some places where these guys actually kind of hit the crosshairs here. So I can see these pretty points here. And I'm going to test those out. Okay, I could pick any pretty points. I have infinitely many pretty points on these, but those were just some I found pretty quickly. So pretty points being right where it hit on the crosshairs. It was easy to see the x and y value, as opposed to like right here. I couldn't really tell if that would be like 1.2 or 1.25 or 1.3. So I want ones that were nice, neat, right on the crosshairs. So I'm going to test that out. Now remember that this one, we're going to try putting in the y value and see what x I get. So these 2 dots actually both have the same y value of 2. I'm going to test that out. So my x given that the y of 2 squared minus 1, let's see what I get. So a y value of 2 should give me a 4, 2 squared is 4, minus 1 is 3. So this dot is not 2, or sorry, it's backwards. It's trying to trick us. 3, 2. That's what it's saying that this should be. So since that is not the dot we have a 1, 2, then this is not going to be my graph. It doesn't match this pattern because a y value of 2 should give an x value of 3. So he's out. So let's actually check our other ones. A y value of 2 should get an x value of 3. Oh, actually, I see that right here. A y value of 2 gets an x value of 3. Now this one's backwards. So if you got in a hurry and put it as 2, 3, like I almost did there at first, then you might have thought that this was your solution because this one does have the point 2, 3. But this one we put a 2 in for the y and got a 3 for the x. So this is actually going to be the one that shows our pattern. This is the only one that had the dot at 3, 2. Now I could double check these other ones just to make sure. This one says that if my y value were 1, I should get an x right here. So let's just double check that just to be extra safe. So if I put in a y of 1 and go x equals 1 squared minus 1. 1 squared is still 1. And of course, 1 minus 1 is 0. So that means that the x value should be 0 with a y value of 1, just like we see right here. This one does not have that. So he again is out. Okay, so the reason it was a good idea to check that second point is because if I didn't make that common mistake where I saw that this one had 2, 3, and I tested one more, you'd kind of catch yourself and say, okay, wait, I should have expected this to happen and it didn't. And that would help you make sure you got it. So on homework where you get those multiple chances, it might not have been as important, but on a test, if this was a problem on a test, you'd want to do that second point just to be extra safe because you're always going to have plenty of time. Take advantage of that time. Okay. All right. So what if they didn't give us the graph? They wanted us to try to display the ordered pairs that would follow a certain pattern. We have lots of different ways, and I'm sure you've covered a lot of these things in previous classes. You might have heard of something, the y equals mx plus b, okay? You might just try to create some ordered pairs like this right here. So if you have a method that you prefer, and it's not what I show you in this video, if that works for you, that's okay. Remember that on a test, I'm not super concerned about how you get your answer as long as you can get it and show me that you got it. So just make sure that you're showing your work. Okay, so if I wanted to find a set of solutions for these guys right here, we're going to scoot this over just a little bit. Okay, find these ordered pairs for these situations. Now, these are some of the special cases. Okay, most of our graphs that we're going to deal with in this chapter are going to look more like this, the linear graphs, and then we kind of advance on and do other shapes like these guys right here. But there are these special cases where you only have one of the letters. Now this kind of relates back to what we did back in chapter 2 where we only had a single variable. But remember back in chapter 2, it was one dimension, we just had the number line. We still have that second dimension. We still have both the left, right, and the up, down. So we have to account for that. So y equals -1 is not a single dot. It's not a single number because it doesn't describe to us what x is doing. So y equals -1 means any y value that's -1, regardless of what x value it has. So a y value of -1, you might think is just right here. While that's true, it's not the only one because this dot right here has an x of 2, but it does have a y of -1. So any dot along this horizontal line has an x value of whatever and a y value of -1. So anytime they give you a graph, an equation like this, where you only have the y value, you can pick any X value you want as long as you keep that Y value the same. And it always ends up creating a horizontal line like this right here. So what do you think the X is going to do? So the X value is now limited to -4. It doesn't give us any information about the Y value, but it does say that no matter what, the X is going to stay at -4. So you might see this one right away, and that's good. Here's an X of -4, but there's more. In fact, there's infinitely many more. There's 0.0001 -4. Should be really close to this guy. My kind of go-to dots, especially since XYZ makes you use 2 dots, are to do this one right here, because most people get that one right away. And then if you're a little unsure about, if it should be the X value staying -4, the Y value is -4, if it should go here or there, say, okay, I know this is the X one. And then for my second dot, I go here, where both the X and the Y are -4. Then you don't have to be as confident. You say, okay, they're both -4. And then you can see, oh, yep, that one created the vertical line. So whenever it limited the X's and the Y's could be anything, it created the vertical line. When you limited the Y's and the X's could be anything, it made the horizontal line. So if I had used that trick for my Y's, I would have put this dot first. And my second dot I would have used right here at -1, -1. And then I would have seen again, it create that horizontal line. Okay. So what about the more usual ones where I do have both the X's and the Y's? So let's kind of build up to it. So if I had an equation like this where I do have the X and the Y, what if I let my X be 0? So it says find Y when X is 0. So just like we did when we were testing points, we say, okay, I'm going to replace the X with the number 0, keeping everything else the same. Okay, so right here, 4 times 0 is still 0. 0 plus Y is just Y. Some people do a -0, that's okay, but it's unnecessary. So right here, I get that Y would be 4, okay? Which means that this one is going to have an X of 0, a Y of 4, written as an ordered pair. Okay, next it says, what would X be if Y were 0? So look, it's that same equation, but this time instead of replacing the X, I'm going to replace the Y. So my letter Y turns into a 0, not a 6, sorry. There we go. So I get 4X plus 0, and actually plus 0, that would just be 4X. There we go. Now this one, I'm not quite done. I do need to solve it for X. So remember, this is 4 times X, which I undo by dividing. So that means I would get an X of 1. So that means this one would create the ordered pair. Be careful of that order. The X is the one, the Y is what we plugged in as a 0. Okay. So if I plotted these 2 points, 0, 4, be careful. For some reason, those zeros throw everyone off, even me. I always have to stop and think zeros first. So it's 0 left and right, 4 up. And then the next dot, 1, 0. That would be 1 to the right, 0 up and down. That actually helps us find the pattern that says no matter which point I pick for the X and Y, I would always end up falling on this line right here. I'm really bad at drawing straight lines. Let me undo that. Okay, hang on, let me make an extra dot for myself to try to make it straight. Be here, right? Yeah. Okay, see if I can do better. So, oh no, what happened? That's weird. Oh no. Okay, I broke everything. Well, that's a new one. Sorry about this, guys. Okay, got it off. Okay, I'm gonna do the straight line, I promise. I'm gonna do it. All right, got it. Okay, so that's a perfectly straight line, I promise. Last, what if I just wanted to solve, okay? Solve for y. Now remember, just like we did in our variables, we just kind of move stuff around. I want y to be by himself. This is why we did all that work, because we typically see that y equals mx plus b format, which means it helps us to solve it for y, because then I can see what we call the intercept and the slope just from the equation of the line. So right here, I have 4x plus y, but I want y by himself. First thing I do is I move over the x. Remember, I can move him over just like any number. So I'm going to move over that whole 4x. And luckily, in this case, that's the only step I have to do. I could write it as 4 minus 4x. Or I could write it as minus 4x plus 4. I'm going to do it this way because, like I mentioned, we have that y equals mx plus b format. So that means that if I write it in this way, I can tell what the slope of the line is and what the intercept is. So the slope is always the one right next to the x here. So it's not about first or second, it's about x. So my slope in this case, like you see, is -4. B is the y-intercept as 4. Okay, so that means in this line, just like we found from our graph, the intercept, the y-intercept was right here at 4, which we saw. And the slope of -4, remember rise over run, means I would have gone down 4 and over 1, rise over 1. And that's exactly what we saw by graphing those two dots. So it all goes together. So really what we did, with a little bit of help, a little bit of guidance, they asked us specifically to put in this x, and we got this y. And then it asked us to put in this y, and we got this x. Okay, I could have used any x and any y, or I could have done it this way by solving for y and using my slope intercept. Okay, so whichever way you prefer to graph your lines, you're welcome to do so. All right, so the last one, the word problem, everybody loves. But this is really just an interpret. So it has the graph for you, it has the information, it just kind of wants you to interpret. So a lot of people just kind of freeze up on word problems. So remember, the first step is always don't freak out, okay? Just read through it, see what you can do. So it says it's showing us the line of people increasing as it gets time for the movie to start. So this one says it's going to start at 7:30. The box office, they don't actually start selling tickets until 6:45. So you see the line kind of builds up. And then as they open and start getting people in, it goes back down again. So first question is, how many people are in line when the box office opens? When did it open? 6:45. That's halfway between 6:30 and 7. So it'd be right around here. If I follow that up with my perfectly straight lines, looks like that is about 70 people. Okay. Sorry, it's hard to write with this little tablet, but my handwriting's not great either, so it's not all that. So there is just a little bit of wiggle room on XYZ. So if you put like 71 people, it usually gives you credit, but you do need to be pretty close. So try your best to kind of watch that, draw some lines if you need to, you know, grab a pencil on your computer screen, hold it up, whatever you need to be pretty close. So the next question asks us for how long after the show starts would we find 10 people in line? Okay, 10 people in line. This isn't the time. This is, of course, the people in line. Now notice that it actually hits the 10 people in line twice. No, sorry. Okay, should be right in there. So this one looks like maybe 6:10, something like that. And then this one looks like a little bit after 7:30, because I think they meant for 7:30 to be right there. Maybe like 7:40-ish, we'll say. All right, so which one answers the question, 6:10 or 7:40? So it says, how long after the show starts? Okay, well, the show started at 7:30, so it's not this one, it's not the 6:10. Now the answer is also not 7:40. Okay, be careful, always read your question. How long after the show starts? So if it started at 7:30, that would be 10 minutes later. Okay, the answer would be 10 minutes. Because 7:40 is 10 minutes later than 7:30. Okay, so just be careful. I do have some people miss problems just from not reading them closely like that, especially on a test. Go back and read the question. Make sure your answer answers that question. Okay, every once in a while it'll have, like length and width. Make sure you answered for the one they asked about, things like that. Okay, so hopefully this helps get things started. A lot of this probably was review, but it's all going to kind of build. So please make sure to make sure, well, like I said, watch this, go back to it again, because sometimes after you get to the more advanced stuff, some of this easy stuff seems blurry for some reason. So come back as needed.